Hello, and welcome to the second day of the Solving Trigonometric unit. This is actually the third day of the unit, second day on the same topic. Here are the homework answers from last night. There's 1 through 4. You can pause it and look at them if you'd like. And here is 5 through 8, and then 9 and 10. All right. Now, yesterday we solved problems that looked like this. So the cosine of theta is equal to negative root 3 over 2. We drew this out, and cosine is going to be negative in these two quadrants. And so we said that it's going to be negative root 3 over 2. 3. And so these would be 1 and negative 1, so those are 30-degree reference angles. So this would be at 150 degrees, and this would be at 210 degrees. So theta is 150 and 210. And another example, if I have where does sine of theta equal 1? Well, there's a few ways that we can look at this. Sine of theta equals 1 when the opposite is the same as the hypotenuse. So it has to be on the axes. One way that we can tell the sines and cosine on the axes is to look at their coordinates on the unit circle. The x value is the cosine, the y value is the sine. So where is the y value 1? Well, that would be at 90 degrees. So on this one, we just have one answer. That's 90 degrees. Today, instead of having sine of theta is equal to something, we're going to have sine of 2 theta is equal to something. Sine of 1/3 theta is equal to something. Or sine of theta plus 30 is equal to something. Now, in a situation like this shrinks my sine function. So if I drew my sine function, it shrinks it by a factor of 2. So it can do 2 revolutions or cycles by the time it gets to 360. So if I want to see where sine is 1/2, there will be 1, 2, 3, 4 answers rather than just 2. And if I do sine of 1/3 of theta, I'm stretching it by a factor of 3. So it does 1 revolution by the time it gets to 360 times 3, which is what, 1080? So 360 is 1/3 of the way, so somewhere over here. So if I want to see all the values between 0 and 360 in this graph, there might only be 1. There could be 2, and there could be 0 if it was a negative number. Now, sine of theta plus 30 moves the graph to the left 30, and then we do our sine. So, so each of these changes the function. Now, so if I do a problem like this, so say if I took sine of, if I have 3 sine of theta plus 55 minus 4 is equal to -1, what I would do is I would solve this just like we did yesterday, but let's assume that there's nothing here, because we can't deal with this mess until we get rid of the sine. So let's solve this like we would yesterday. And first I would add 4. So I'd have 3 sine of theta plus 55 equals 3. And so that moves there. So now I would divide by 3 on both sides. So I'd have sine of theta plus 55 is equal to 1. And still, let's do this. If I had sine of blank equals 1, well, we just did that. On this problem, sine of theta equals 1, and we found out that that answer was 90. Oops, it's a little too far. So this answer is 90. So so I broke this down so I did the inverse sine. So now what I have left is just the theta plus 55 is equal to 90. So if I subtract 45 on both sides, subtract 45, now theta is going to be 45. So that is my only answer for this problem, 45. Now let's try this. This says, oops, square root of 3 tangent of x plus pi over 6 plus 5 is equal to 4. I'll subtract 5 on both sides. So I have root 3 tangent of x plus pi over 6 is equal to negative 1. Next thing we do is we divide by square root of 3. So tangent of x plus pi over 6 is equal to negative 1 over root 3. Now it doesn't matter if we rationalize that or not. Sometimes it's easier to just leave it in this form until we're done with the problem. So if I want to get rid of this tangent, I need to figure out what values tangent is negative 1 over root 3. So if I drew this all out, opposite is going to be 1 or negative 1. And down here, this will be 2 negatives, so that won't work. These are both going to be positive. So these are the two quadrants where we can find the tangent of something equaling negative 1 over root 3. So over here, that will be 5 pi over 6. And over here, it'll be 11 pi over 6. So we have to write two separate equations. We have to say that x plus pi over 6 is equal to 5 pi over 6. And we have to say x plus pi over 6 is equal to 11 pi over 6. Now what we do is subtract pi over 6 on both sides. And 5 pi over 6 minus 1 pi over 6 is 4 pi over 6, which can be written as 2 pi over 3. And if I subtract pi over 6 over here, I'll get 10 pi over 6, which is 5 pi over 3. All right, so you have two answers for this problem. All right, now this one is a little bit different, the cosine of 3 theta, because it shrinks the function by a factor of 3. So let's first do this problem as if it was just, say, theta or circle. So we want to see where the cosine will be 1/2. We'll have 1 over 2's. Now on these other two quadrants, it would be a negative 1 over 2. So it's not going to work on the left side. So this is at 60 degrees and 300 degrees. So if I remove my circle, I'll have 3 theta is equal to 60, and 3 theta is equal to 300. Now, we know that cosine of 3 theta means we can do 3 functions by the time we get 3 cycles by the time we get to 360. So the cosine of 3 theta equals 1/2, that crosses here, meaning there's going to be 1, 2, 3, 4, 5, 6 different answers. Since there's so many answers, this will only give us 2 answers. What we have to do is we have to look for more answers by adding 360k on the end of this. So what that means is 60 is an answer here, but we could also add 360 to it to get 420, and the cosine of 420 will also be 1/2. If I add another 360 and get 780, that will also give us 1/2. Same with down here. I can add 360 to get 630, 960, and we can keep going and get an infinite number of values. So we're going to write that equation as 60 plus 360k, or 300 plus 360k. Now if we divide each side by 3, my theta will equal 20 plus 120k, because I have to divide both of those by 3. And this will be 100 plus 120k. That's supposed to be a k. Hopefully you can read my writing. All right, so now my values from this one are going to be 20. 20 plus 120, which is 140. 140 plus 120, which is 260. 260 plus 120, which is 380. And that's above our 360 threshold. Our next one, we'll have 100. Add 120 to that and get 220. Add another 120 and get 340. And then if I add another 100, of course, or add another 120, that's going to be over. So on this problem, I have my 6 answers. All right. Now let's see if you guys can do this problem on your own. So pause the video and see how far you get. The first step is to know where sine is going to give us these the exact value of negative root 2 over 2. And it's in these two sections where this is a 45, 45, 90 triangle. So this will be 5 pi over 4 and 7 pi over 4. So now we have two equations. X over 2 is equal to 5 pi over 4, and x over 2 is equal to 7 pi over 4. Now, we could also add on to this plus, instead of 360k, it's plus 2 pi k, plus 2 pi k, because we're dealing in radians. All right, so now to find my value of x, instead of dividing here, I multiply it by 2. So if I multiply this by 2, this would be 10 pi over 4 plus 4 pi k. And over here, it would be 14 pi over 4 plus 4 pi k. So this is 5 pi over 2. And this one is 7 pi over 2. So this is over 2 pi. And if I add or subtract 4 pi from it, I don't get in the range between 0 and 2 pi, like we're looking for. And same with this one over here. This is 3.5 pi. And if I subtract 4 pi, it'll be negative. If I add 4 pi, it's too much. So in this problem, there are no values that are going to work. Now, if we want to look at a graph of this, I'll graph this off to the right. Sine goes like this, and this 1 over 2 is going to be a horizontal stretch. So instead of doing a rotation by the time it gets to 720 or 360, it does it by 720. So halfway is 360. So if I'm looking for all the values that sine is going to give us a negative root 2 over 2 between 0 and 360, notice how there's no values down here. It doesn't hit the graph at all. So our answer for this one is no solutions. All right, try this one. 2 sine of 1/4 x equals square root of 3. First step, we divide by 2 on both sides, so sine of 1/4 x equals root 3 over 2. Now we want to get rid of the sign. To get rid of the sign, what we have to do is see where the sign is root 3 over 2, which will be these two quadrants. It'll be negative down here. So this will be at pi over 3 and 2 pi over 3. So I can make two equations out of this. The equation on the left is going to be pi over 3 is equal to 1/4 x plus 2 pi n, or k. Over here we do 2/3 pi equals 1/4 x. I did that in the wrong order. I was thinking about something completely off of this lesson. So let's try this again. 1/4 x is equal to pi over 3 plus 2 pi k, and 1/4 x is equal to 2/3 pi plus 2 pi k. So now we got to multiply each side by 4, and x is going to be 4 pi over 3 plus 8 pi k, and x will be 8 pi over 3 plus 8 pi k. All right, now 4 pi over 3 is between 0 and 2 pi. However, 8 pi over 3 is past it, because 6 pi over 3 is 2 pi, and this is larger than that. So if I add or subtract 8 pi to either of those numbers, it won't work. So 4 pi over 3 is my only answer. All right, try this one. Pause the video, see how it goes. First thing we do is add 3 to both sides. So we have 4 tangent of 3 theta is equal to 2. 4. All right. Couple mistakes here. Is equal to 4. Then we divide by 4. Tangent of 3 theta is equal to 1. Now we need to get rid of this tangent. To get rid of this tangent, what we do is see where tangent is equal to 1. And it's in these two quadrants. And that's when we have a 45-degree angle. So it's going to be 45 and 225. So 3 theta is equal to 45 plus 360 n. And 3 theta is equal to 225 plus 360 n. Divide both sides by 3, and we'll get theta is equal to 15 plus 120 n. And if we divide 225 by 3, we get 75. So theta is equal to 75 plus 120 n. So if I want to list out all the values, 15, add 120 to that to get 135, add 120 to that to get 255, add another 120 to that to get 375, which is too much. Then we can start at 75, add 120 to get 195, add another 120 to get 315, add another 120, and we are over. So those are the 6 values that work. All right, now you can do your second worksheet, and you can finish that second worksheet. All right, hopefully that helps.